Hello everybody, my name is Ricardo Arencibia and I am researcher at the Complexity Science Center of the National Autonomous University of Mexico. I'll be presenting here the results of a collaboration that exposed a new thematic dispersion index which could be applied to analyze multidisciplinary scope of research developed by a professor, an institution, a country, or even a research field of a given knowledge area. Let's take a brief look at the definitions. First, disciplinary research involves spaces where people just come from one particular background, for example, chemistry, physics, biology. In the next level, researchers recognize that sometimes are necessary multiple perspectives to face a problem. There is a little interaction across disciplines, they still are not really integrated in any way, but there is a multidisciplinary work. Interdisciplinarity is all about putting those disciplines to work together, involving a new level of integration and breaking disciplines' boundaries. For example, research on biosensors, nanodevices, or bioinformatics. Finally, in a transdisciplinary research, disciplines' perspectives transcend each other to form a new holistic approach where stakeholders are involved, as well as social impact. For example, research on ecology, sustainable development, or quantum cosmology. From a sociological perspective, there is no confusion here, but from a scientometric perspective, it is a challenge to design metrics for this kind of problems. There are two methods described in the literature to face this challenge. A bottom-up approach based on grouping set of articles according to bibliographic coupling or co-citation networks, and a top-down approach dependent on existing classification schemes. A lot of diversity measures have been proposed by many authors, but the crucial point is always the classification of papers. Having this into account, we understand that when multi, inter, or transdisciplinarity is on the focus, there is a wide range of publication biases, and usually papers are published in journals covered by one, two, or more disciplines, and even in multidisciplinary journals such as Science or Nature. So, our top-down approach used the Web of Science list of subject categories to design a new set of bibliometric indicators which takes into account documents produced by an entity and documents influenced by this entity. We analyze the knowledge domains, research institutions, and individuals, and we try to identify how elements from different disciplines are present in the scientific output of entities and in their spheres of influence. During the design of the indicators, we considered the power law nature of many bibliometric distribution, and we decided to use the Pareto principle to build the basement of the Thematic Dispersion Index. Of course, the whole output of an entity and their citing articles would be covered by a lot of Web of Science subject categories. But what about 80%? Which is the minimum number of subject categories necessary to cover approximately 80% of papers and citing papers? Can this core of disciplines represent the specialized or multidisciplinary nature of research? That was our goal here. The procedure is easy and well described in the poster available at the conference proceedings. We calculated the thematic concentration in papers produced by entities and papers influenced by entities, and then we calculated the square root of the product of both measures to obtain the thematic dispersion index. We decided to apply the new indicators to analyze research on solar flares, ethnomethodology, and artificial intelligence, three completely different topics. We used basic search strategies and we analyzed 5 years stages for each case during the last 60 years. We also studied the last 10 years of 8 research institutes belonging to our university, and finally we analyzed the whole career of each senior researcher at the Mexican Complexity Science Center. Let's see the results. At macro level, each of the 3 studied datasets show an exponential growth of scientific output and a linear growth of the subject categories involved. However, our measures show a different behavior during the whole period. For example, research on solar flares showed the classic disciplinary behavior, with no variations during the whole period and with less than 5 subject categories involving 80% of papers and citing papers. Astronomy and astrophysics was the dominant category. Research on ethnomethodology was less productive than research on solar flares, but the growing trend of the studied measures was observed. This put in evidence the gradual transition from a very specialized topic of sociology during the first 30 years to a transversal methodology used nowadays by professionals from multiple disciplines, including library and information science. Finally, research on artificial intelligence showed a seesaw behavior which could be related to epistemological highlights within the field. After an initial expansion of topic between 1970 and 1994, research evolved to a paradigmatic phase of development, and you can see the consolidation of the field becoming a more specialized research. And then, since 2010, a reconfiguration of the discipline as a technoscience was observed, involving an explosion of technological solutions for productive systems, which implied, again, the growth of the subject category score. We consider that the Thematic Dispersion Index here could contribute to delineate the evolution of a research topic. At the institutional level, it was clear the differences between the Complexity Science Center and the Mexican Institute of Applied Maths during the last 10 years, respecting the other Mexican institutes. In the first case, the center studies the dynamic of complex systems, gene regulatory networks, biology of systems, innovation, ecology, biodiversity, climate change, using computational intelligence and self-organizing models. This requires a holistic vision that can only be possible through the adoption of an interdisciplinary perspective. Of course, this wide scope had also been an impact on multiple research areas, and this is well reflected by our indicators. In the second case, the transversality of research on applied math is an implicit characteristic of the institute, which was also reproduced by our measures. Complexity Science Center was also chosen for the analysis at micro level. Each bubble here represents an individual. The size indicates their whole scientific output in Web of Science. Colors represented the scientific field of their PhD. So, we have a multidisciplinary staff involving at least 8 disciplines. The diversity of the staff composition and the complex nature of the study problems at this institute were clearly revealed by our indicators. Thematic Dispersion Index was higher than 5 in 69% of cases, and even higher than 10 in the 34%. Therefore, even at the individual level, our set of indicators was useful to assess the multidisciplinary research scope. Of course, we are aware of our limitations. Science is a complex system, and its research problems have methodological, epistemological, and ontological dimensions. Bibliometric methods tend to reduce the complexity of science to specific disciplinary criteria. But a solution for this is to have a robust battery of indicators available to get difference measures from any part of the system. Our indicators could be included in that toolbox. In our approach, the multidisciplinary scope must be complemented with diversity measures in order to find evidence of knowledge integration in the identified course. On the other hand, journal indexation process in databases is traditionally based on the journal scope, and many authors doubt about the analytical clarity of subject categories for normalization in evaluative assessments. But this can be further solved by an indexation process based on the article's content. So, we can conclude that in spite of the limitations of classification schemes, our new approach obtains a less size-dependent subject category score, which allow it to characterize the thematic dispersion of research developed by entities at macro, meso, and micro level. In each of the analyzed datasets, 80% of published documents and citing articles were representative of the main research lines generated and influenced by an entity. This basic approach must be complemented with diversity measures, which could be identified in greater depth the levels of knowledge integration in the research fronts. And this is what we are doing right now. We are very grateful for your attentions. We are confident that your feedback will help us to improve our indicators. So, thank you very much in advance.